Hello. And welcome to another fantastic, action-packed, awesome edition of Phillips Podcast, or P Squared. By the end of this podcast, you should be able to identify different types of triangles, and you should also be able to solve for a missing angle or missing angles in a given triangle. Vocabulary words we will cover in today's podcast. We'll talk about an isosceles triangle. We'll talk about scalene triangles, equilateral triangles, we will talk about angles that are congruent. We will talk about acute angles and also acute triangles. And there should be one more hiding in here. I'm not lying, there really is one. I told you there was one more. See, just had to be patient. Obtuse angles we'll talk about, and obtuse triangles. Today's podcast is on lesson 5.2, angles and sides of triangles. Remember that every triangle adds up to 180 degrees. Or you can say the sum means add. When you add up all the angles in a triangle, all the angles in a triangle have to add up to 180 degrees. I'll show you two different strategies to find the missing angle or x in the problem. You pick the strategy that's easiest for you. First strategy is I'm going to write an equation. So I'm going to say 28 degrees plus 50 degrees plus x, or our variable, has to equal 180 degrees. Why? Every triangle has to add up to 180 degrees. So I'm going to write myself an equation. I have 28 degrees plus 50 degrees plus my variable x equals 180 degrees, because every triangle has to add up to 180 degrees. The sum of the angles have to equal 180 in a triangle. Now that I have my equation, hearts and stars combine like terms. These will be my hearts. This will be my star. Since these hearts are on the same side of the ocean or line, I'm going to put them together, and I'm going to add 28 degrees and 50 degrees. If I do that correctly, it should give me 78 degrees. I will write the rest of my equation. Hearts and stars combine like terms. I'm going to bring the 78 degrees over to the other side. And when I cross the line, I do the inverse. The inverse of 78 is negative 78 or minus 78. When I subtract 78 from 180, that should give me 102. So I say x is equal to 102 degrees. The missing angle in this triangle is 102 degrees. This is a reminder that an acute triangle has all acute angles. A right triangle has one right angle, and an obtuse triangle has one obtuse angle. Let's go back and look at our triangle. We have 28 degrees. That is acute, so put the letter A. We have 50 degrees. That is also an acute angle. I'll put the letter A. And we have 102 degrees, which is an obtuse angle. If I come back and look at my definitions, an obtuse triangle has one obtuse angle. I have one obtuse angle, 102 degrees. So by definition, we say that this is an obtuse triangle. An obtuse triangle is any triangle that has one obtuse angle. Okay, same problem, use a different strategy. You pick the strategy that works best for you. I'm going to take the 28 degrees and 50 degrees and add them together. When I add them together, that's going to give me 78 degrees. I know that the sum of the measures of the angles in any triangle is 180 degrees. So I know that I have to get to 180 degrees. I'm at 78, so I'm going to do 180 minus 78. When I do that, I get 102 degrees. So x is 102 degrees. You can set up an equation like we did the last time, or you're going to add the angles that you know and subtract from 180. In both cases, we got an answer of 102 degrees and an answer of 102 degrees. So you pick the way that's easiest for you. All right, let's solve for the missing angle in this triangle. I'm going to use the second strategy. I'm going to add what I know. So I know this is 59 degrees, and I know this is a right angle, or 90 degrees. I'm going to add what I know, 59 degrees and 90 degrees. When I add them together, that gives me 149 degrees. I know by definition that the sum of the angle measures of any triangle is 180 degrees. So 59 degrees, 90 degrees, and some number, x, have to give you 180. Since I have to get to 180, I'm going to do 180, take away 149. That gives me 31 degrees. X is 31 degrees in this problem. If I ask you to identify what kind of triangle it is, remember, I can have an acute triangle, a right triangle, or an obtuse triangle. A right triangle has one right angle. A right triangle has one right angle. So, by definition, we can say this is a right triangle. And the reason why it's a right triangle, have one right angle. If I ask you to identify this triangle by the measurement of the angles, you should be able to see that you have 65 degrees, which is an acute angle, 60 degrees, which is an acute angle, and 55 degrees, which is an acute angle. By definition, an acute triangle has all acute angles. I have all acute angles. So this is an acute triangle. All right. An isosceles triangle. Isosceles triangle. Here's a picture of an isosceles triangle. By definition, an isosceles triangle has two congruent sides and two congruent angles. By definition, an isosceles triangle has two congruent sides and two congruent angles. You usually can tell if it's an isosceles triangle because they will use small line segments to indicate the congruent sides. So right here, they're going to use small line segments, hash marks, tick marks, to indicate that these two sides are congruent. Plus 10 if you said congruent means equal. Speaking of equal, an equilateral triangle. Here's a picture of an equilateral triangle. Again, you can see that they use small line segments to indicate the sides are congruent. Here's your small line segments, hash mark, tick marks, indicating that all three sides of the triangle are congruent. Plus 10 for you. You said congruent means equal. So I'm going to write the definition of an equilateral triangle. Has three congruent sides and three congruent angles. Equilateral triangle. Some kids in the past have said, Mr. Phillips, equilateral triangle is pretty easy to remember because at the beginning of equilateral triangle, it almost looks like the word equal. If I asked you what the measurement of the angles are in an equilateral triangle, all three angles have to add up to 180. So I'm going to take 180 and divide it by 3. Mental math, 18 divided by 3 is 6. Stick on a 0. Each of these angles would be 60 degrees. Remember, it's an equilateral triangle, so all three angles have to be the same. All three angles have to be congruent. 6 and 6 is 12. 12 and 6 is 18. Tack on a 0. 18 with a 0 behind it. 180. Special name for the angles in an equilateral triangle. We say the angles in an equilateral triangle are equiangular. They're all equal. All right, sometimes they will give you 3 different measurements, 3 angles, and they will ask you, do the 3 angles make a triangle? Easy pleasy. All you have to do is take 3 measurements, 3 angles that they give you, add them together, see what it gives you. So take your handy dandy calculator. Ooh, you don't have a calculator? Minus 10 for your group. Go grab one. When I add all 3 angles up, it does give me 180 degrees. So by definition, yes, these measurements form a triangle because when you add them together, you get 180 degrees. All right, we're going to work out some problems. Some of them will be new problems from lesson 5.2. Angles from triangles, different types of triangles. Some of the problems will be a review from lesson 5.1, different types of angles. So first thing I'm going to do is I'm going to look at this picture and I'm going to ask myself, is this an equilateral triangle? No, because for it to be equilateral, all three angles would have to be 36. And if you did 36 times 3, that only gives you 108. And you're right, plus 10 for your group, you need to get to 180. So it can't be equilateral. Scalene triangle. This is not a scalene triangle. A scalene triangle, all three sides, all three angles are different, and these two angles are congruent or the same, so it cannot be scalene. Last type of triangle I'm going to try, isosceles. I think I remember that an isosceles triangle has two congruent angles and two congruent sides. So I'll solve this problem by writing an equation. If you want to use the other strategy we used early in the podcast, go ahead and do it your way. We should still get the same answer. So here's my equation. X plus 36 degrees has to give me a total of 180 degrees because the sum of the measures of a triangle have to be 180. So I'm going to write myself an equation. X plus X plus 36 degrees has to equal 180 degrees because there's always 180 degrees in every triangle. Excellent job if you use the word coefficient because there's an imaginary coefficient of 1 in front of both of these x's. Plus 20 for your group if you said that. I'm going to do hearts and stars. Combine like terms. When I bring 36 across the line, the inverse of adding 36 is subtracting 36. When I subtract 180 and 36, that gives me 144. I'm going to combine, put my parts together. 1x plus 1x. 1 plus 1 gives me 2. Roof, roof. Dog follows you everywhere you go. My equation now is 2x equals 144. When the 2 is touching the x, that means multiplication. The inverse of multiplication is, excellent job, division. We write division with a good job fraction bar. Divide both sides of the equation by 2. Bada bing, bada boom. X equals 72 degrees. Excellent job. If you said, Mr. Phillips, you could check it by plugging and chugging. If x is 72 degrees, I have 72 degrees here and 72 degrees here. To check it, you take 72 degrees, 72 degrees, 36 degrees, and add them all together. When you do that, 72 plus 72 plus 36 does give you 180. Excellent job. Plus 10 for your group for checking your answer. An airplane leaves from Miami and travels around the Bermuda Triangle. What is the value of x? I'll work this problem using the second strategy, adding what I know and then subtracting. If you'd like to write an equation for this one, write an equation. See if you get the same answer that I get. Pick the way that's easiest for you. I'm going to say 62.8 degrees plus 63.2 degrees. I'm adding together what I know. When I add these two together, that gives me 126 degrees. I know the sum of the measures of the angles in a triangle have to give me 180 degrees. So since I have to get to 180 degrees, I'm going to take 180, subtract 126 from it. Bow wow, chicka bow wow. When I do that, I get 54 degrees. X would be 54 degrees. Excellent job. Plus 20 for your group if you correctly identified this as an acute triangle. And you said, Mr. Phillips, all the angles in this triangle are acute. Therefore, it is an acute triangle. And plus 20 for your group on the last problem if you also correctly identified the triangle as being 1 isosceles and 2 an acute triangle, because all the measures the angles in this triangle are acute. So this is an isosceles acute triangle. Next problem, find the value of x. Well, I can work the problem two different ways. Here's the easiest way. I'm going to ask myself, what kind of triangle does this look like? Well, I'm thinking it doesn't look like a scalene triangle, because scalene, all the sides are different. I'm thinking maybe isosceles, but I don't think so. I'm thinking it looks like an equilateral triangle where all three sides are equal. If it's an equilateral triangle, all three angles must be equal. Nice vocab, plus 10 for your group, or congruent. So I'm going to guess that this is an equilateral triangle. Therefore, all three angles have to be 60 degrees. I'm going to check my answer just to make sure it's right, and by checking it, I'm going to write an equation. So I have x plus another x plus 60 degrees. Every triangle has to add up to 180 degrees. Don't forget, you have an imaginary coefficient of 1. Combine like terms. Excellent job. Hearts and stars. Bring 60 across the line. When you do that, you do the inverse, which is minus 60 or negative 60. When I subtract, it gives me 120. 1 plus 1 gives me 2. Excellent job. You shouldn't have reminded me. The dog follows you everywhere you go. Divide both sides of your equation by 2. 12 divided by 2 is 6. Bring down your 0. X equals 60 degrees, which is what we had. Plus 20 for your group if you said this is an equilateral triangle, and it's also an acute triangle because all three angles in this triangle are acute. All right, here's a review problem from lesson 5.1. We want to find x. Excellent job. Plus 10 for your group if you said, Mr. Phillips, this is a straight line or straight angle, and every straight angle has a total of 180 degrees. Plus 10 for your group if you said these two angles are supplementary to each other. Nice vocab. So since I need to get to 180, easiest way to do the problem would be 180, take away 34, because that's what I know. When I do that, I get 146. X would be 146 degrees. Plus 10 for your group if you said to check your answers, see if it's correct. Add them together. It does give me 180. BRB. All right, guys, ask yourself, is this a scalene triangle, equilateral triangle, or isosceles triangle? I'm going to guess that's an isosceles triangle because they gave me two line segments telling me that these two sides of the triangle are equal or congruent. So I'm going to write myself an equation. X plus X plus 128 degrees equals 180 degrees. There's always 180 degrees in every triangle. So let's write our equation. X plus X plus 128 degrees equals 180 degrees. Don't forget you have a coefficient of 1 in front of both x's. Now I'm going to do hearts and stars. You got it. Combine like terms. Your choice. You can put the stars together first or the hearts. It doesn't matter. I'm going to put my stars together first. When I take 128 across the line, the inverse of adding 128 is subtracting 128. When I subtract 128 from 180, that gives me 52 degrees. 1 plus 1, 2. Dog follows you. Roof, roof. Everywhere you go. 2x equals 52. Inverse of multiplication, division. We write division with a fraction bar. Divide both sides by your coefficient. Nice vocabulary, Mr. Phillips. Up to. ALC, 52 divided by 2 gives you 26. X is 26 degrees. Plus 10 if you told me to check your answer, Mr. Phillips. Plug and chug, 26 degrees for each of the x's, and add 26 and 26, which should give you 52. 52 and 128 does give me a total of 180, so it does check. Excellent job checking your work. A review from podcast 5.1. I'm thinking, if you use a nice vocabulary word, plus 10, complementary angles. Complementary angles are two angles that have to add up to 90 degrees. So simply do 90 minus what you know, 74. When you do that, you get 16 degrees. X is 16 degrees. Plus 10 if you checked your work by adding 16 and 74. When you add 16 and 74, it should give you 90. Find the value of x. I'm thinking that I have intersecting lines. When I have intersecting lines, that forms, excellent job, vertical angles. Shouldn't have said anything, it would have been minus 10. Thanks for helping me out. Vertical angles. Angles formed by intersecting lines, and vertical angles are congruent. Congruent means equal. So 2x plus 8 is equal to 54 degrees. I'm going to write myself an equation. 2x plus 8 equals 54 degrees. Hearts and stars, combine like terms. (54) minus 8 would be 46 degrees. Divide both sides of your equation by 2. Uh, 46 divided by 2 should give you 23 degrees. Excellent job if you said, Mr. Phillips. Check your work. Plug and chug. 23 degrees for x. So I have 2 times 23 degrees, which would give me 46. I'm going to add 8 to 46. When I do that, it gives me 54. Bada bing, bada boom. They match, and you got yourself 10. Good job. What is the measure of angle 1? I'm thinking straight line, straight angle. Straight line, straight angle is 180 degrees. I'm thinking these are supplementary angles. Supplementary angles add up to 180. Easiest way, I need to get to 180. I'm at 115. Subtract. Angle 1 would be 65 degrees. Check your answer. Add 65 and 115. It gives you 180. Find the value of x. Vertical angles are formed by intersecting lines. Vertical angles are across from each other. Vertical angles are congruent or equal. So if this is 59 degrees, by definition, x has to be 59 degrees because they are congruent or vertical angles. What is the measure of angle 3? Two angles to form a straight line are supplementary. Or you can say, I need to get to 180 degrees because it's a straight line. I'm thinking it's going to be like one of the problems we just did a minute ago. 180 minus 115 gives you 65 degrees. Angle 3 is 65 degrees. Check your answer. Add 115 degrees and 65 degrees. When you do that, bam, you get 180. You're right. Almost there. Find the value of x. I'm thinking, ooh, minus 10. That was a horrible line, Mr. Phillips. There we go. These are supplementary angles. Supplementary angles make a straight line or add up to 180 degrees. So I'm going to write myself an equation. 2x plus x plus 18 has to give me 180 degrees because this is a straight line, straight angle. And you got it. Hearts and stars. There's rock and roll. Excellent vocabulary word. You need to throw a coefficient of 1 there. Your choice. I'm going to put the stars together first. Subtract 18. Gives us 162. 2 plus 1 is 3. And as always, dog follows you everywhere you go. Divide both sides of your equation by the coefficient of 3. 162 divided by 3 gives you 54. X is 54 degrees. Excellent job. Plus 10 for your group if you said Mr. Phillips. So check your answer. Plug and chug, put in 54 degrees for x. 2 times 54 gives you 108. Plug and chug, put in 54 for x. 54 plus 18 should give me 72. Mr. Phillips, we have a problem. One side is 72, one side's 108. We must have made a mistake somewhere. Nope, plus 10 bears. Because you forgot that they are supplementary angles where they have to add up to 180. So take your 108 and your 72 and add them together. Bada bing, bada boom. Now plus 10 for your group. They add up to 180. You got it. All right, the last one. What is the measure of angle 2? Easy pleasy, as easy as the Cubs lose. By definition, I have intersecting lines. Intersecting lines form vertical angles. Vertical angles are across from each other. Vertical angles are congruent. Congruent means equal, the same. So by definition, these two angles have to be vertical angles and they have to be congruent. So if this is 115 degrees, angle 2 has to be 115 degrees also. Alrighty. Hope you enjoyed lesson 5.2. Stay tuned for our next podcast on lesson 5.3 when we get into similar triangles. As always, see ya. Wouldn't want to be ya.